Okay, we're going to graph some sine and cosine graphs. The normal sine graph comes from the unit circle where we unwrap it, and we always have it starting at 0, and then we have pi over 2 or 90 degrees, pi, 3 pi over 2, and 2 pi. We can also go clockwise where we have minus pi over 2, pi, minus 3 pi over 2, and minus 2 pi. A sine wave normally goes from 1 to minus 1, and we have a point up here, a point down here, a point down here, and a point up here. And then we come along here and we have a point, a point, a point, a point. Now keep in mind, it goes forever in both directions, and this is your normal sine wave, which you can verify on your calculator. Now when you have the pink one where it is actually stretched vertically, instead of going at -1 to 1, it goes up to 2.5. So what we're going to do is we're going to put 2, 3, so about here is 2.5, 2, 3, and about here is -2.5, and this literally gets stretched. Let's see, I'm going to put a line there. So it goes like this. Same intercepts, it just gets stretched vertically. And a normal sine wave has a period of 2 pi. So this is the stretched version. Now a normal cosine wave starts at 1, goes here to 0, comes back around here to -1, over here to 0, and back up here to 1. And it does the same thing going in this direction at these points. Now keep in mind it goes on forever. Now when you see a -2, that means it got flipped and then stretched. So what we're going to do is start it down here and then go back up to here and come back down here, and we'll just keep, because it got flipped, and it goes on forever again. Now that is the difference between these two, and you can verify these on your calculator. Now back to the regular cosine. Starts here, 0, down here at -1, over here at 0, and these are the same values that happen on the unit circle. So you're just taking them and putting them into this kind of graph, and it goes up and down and back up again, and it keeps going forever. And this goes down and up, and it keeps going forever, okay? Now if you'll notice, this looks like it's going to be a horizontal stretch. I know you're looking at it as 1/8, but you can look at it and say a normal cosine is in 2 pi radians. That's a normal cosine. However, we're going to do and make 1/8 of it in 2 pi radians. Another way to look at it is that your period for this new one is going to be 2 pi divided by 1/8, which is 16 pi. So what we have here is that this particular graph is going to make one complete cycle in 16 pi radians. This will happen much more frequently, and this one will really be stretched horizontally. So what you could do is you could put it into your calculator, because I don't have a big enough graph. But basically what I've got is that if I start here at 0 and I take this all the way to 16 pi, then I will make one complete cycle, which means this particular point would be at 8 pi. And this particular point will be half of that, which is at 4 pi. And I know this is not to scale. And this particular point will be halfway between these two, which would be at 12 pi. Now I don't have it to scale, but it still starts at 1. And it would actually go 1 to 4 to 8 to 12 to 16. And so it's not to scale, so don't think that it's going to be exactly like this. And of course, this goes way out here. And it's going to get stretched horizontally. Now this is not to scale, but if you looked at it on your calculator, this is what you would get. First thing you need to do is make sure you are in radian mode. Go up to y equals, clear, and you're going to put in cosine x, and I'm just going to put zoom 7. This puts it from negative 2 pi to 2 pi. Now, if I want to show this one with a regular period of 16 pi, then what I'm going to do is I'm going to go back to y2. I'm going to put in cosine x divided by 8. And before I hit graph, I could, you'll see that it gets stretched out, and some of you will think that it's just a line. So it doesn't really give you a good picture. So what I'm going to do is go back to my window. I'm going to change this to negative 16 pi. And I'm going to come down here to 16 pi. And I'm going to put this in pi radians. And let's see what it looks like. So now the first one you see is y equals cosine x. And now you'll be able to see the other one, how it gets stretched horizontally. That's what happens here. All right, the next problem says we have a bass tuba that can hit a note with a frequency of 50 cycles per second, known as 50 hertz, and an amplitude of 0.75. Now we need to write a cosine function for this to model the initial behavior that the sound wave has. So we're going to look at 50 cycles per second. So what I want to do is a period is 1 over the frequency. So I'm going to say 1 over 50 cycles in a second. So cycles per second. Now y equals 0.75 cosine, and I've got to find how to change this to 2 pi over b, and I have to solve for b. So what I'm going to do is I'm going to cross multiply, and I get 100 pi is my b. So what I'm going to do now is I'm going to call this 100 pi, and I'm going to times it by time so I can get rid of the seconds. That's how you would do this. This one we're given the equation and we need to find these things. Now remember, the amplitude is always the number in front that's multiplied by the sine or the cosine. So the amplitude is 2. Now before I can do anything, I'm going to factor out the 5. That'll help me find things related to the phase shift. And I need to know what this question mark is. So over here, I'm going to say 5 times a question mark gives me pi over 4. Now what I've got to do is find that question mark. Well, that's pi divided by 20. So I'm going to write pi divided by 20. So now my phase shift is such where I went left, pi over 20. My period is going to be, the period is going to be 2 pi divided by b. Well, my b is 5, so it's 2 pi divided by 5. And my frequency is just the reciprocal. And that is how I would find it. Now, I could say left, or I could write negative pi over 20, which tells me I move to the left. One last thing left to do, and that is to graph this equation. It's a regular sine wave that is vertically stretched to 2 and down to 2. There's no vertical up or down. And I went to the left, so I'm going to put this, let's see, I'm going to put this as negative pi over 20. I'm going to ignore this. And I have to go a period of 2 pi over 5. So I'm going to draw my regular sine wave. 1, 2, and I need to graph 2 periods. So I'm going to do this twice. Now keep in mind, I'm not going to worry about this because it's hard to shift, so I'm just going to rearrange my scale. So I graphed 2 of them. Now the distance from here to here, according to my period, is 2 pi over 5. So what I'm going to do is I'm going to take negative pi over 20 and I'm going to add 2 pi over 5, which is going to give me a 7 pi over 20. And if I want to know what the next one is, the 7 pi over 20, I'm going to add another 2 pi over 5, which again is 8 over 20. So I'm going to get 15 pi over 20, which is 3/4 pi. Okay, so I reduced it. And halfway between these two is just going to be pi over 5. So if I need to know these points as well, I can find them because it is halfway between. So if I take negative pi over 20 and I add pi over 5, I'm going to get 3 pi over 20. And if I